today we're covering 1.4. This is the last section in chapter 1 that we're covering. And then as a reminder, your quiz is on Friday, and that will cover sections 1.1 through 1.4. Okay, so the next couple of days we are reviewing. By the end of today, you are going to be able to fit scatterplot data using linear models. We're going to do that with and without a calculator. And then we're also going to use the linear models to make predictions. This type of math is used a lot in statistics. Insurance companies use models a lot to create a model of their data, and that's how they decide what to charge people. Now, it's not usually a linear model, but really by a model, in this case, I really just mean an equation. So we're going to find an equation that fits the data. And we're also going to be making scatter plots today. So I'm going to show you page 32 in just a second when we talk about correlation. Correlation is how the data is related to each other. And you can see this is called linear regression. Regression is just the relationship between the data. So we're going to draw and label the 3 types of linear regression. And it has to do with the slopes. Okay, so I'm gonna show you this on page 32. I'm gonna show you that real quick, and then we're gonna draw them out ourselves. Okay, so here are the different types of correlation. You can have positive correlation, negative correlation, or relatively no correlation. So if you look at the positive correlation, it looks like a positive linear function. Okay, it would be going up from left to right. For negative, it would be going down from left to right. And then if there's no correlation, notice that the data points are spread out all over the place. So we can't see that there's positive or negative correlation because it's scattered. Okay, what we do try to do is find a line of best fit. If you have relatively no correlation, then you won't be able to find a line that is strongly related to the data. Okay, so we're going to draw those out. Okay, the positive correlation, the negative correlation, and relatively no correlation. So we have positive with the positive slope, negative with the negative slope, and then relatively no correlation. What we're going to try to find for all of those is the line of best fit. And the line of best fit is going to fit the data as closely as possible. And we're going to use that to make the predictions. Now, once we create the line of best fit, there's something that is called the correlation coefficient, and that's going to tell you how strongly the data is related. so positive is going up from left to right, negative is going down, and then these are scattered all over. And then once we find that line of best fit, we want to know what that correlation coefficient is, because that tells us if we have a really good model or a really weak model. So that tells us how well the data is fit by that equation that we found. And again, today we're dealing with linear models. So we're going to be finding linear equations. Okay, so the correlation coefficient R is going to be somewhere between -1 and 1. Okay, so many a time it will be a decimal. The closer that that decimal is to 1 means that it has a strong positive correlation. Okay, the closer that it is to -1 means it has a strong negative correlation. If it is further away from 1 or -1, okay, if it's closer to 0, then that means that the correlation is weak. So I'll say that part again. The closer it is to 0, that means that it's a weaker correlation. So close to 1 or -1 is going to give you the strength. Okay, there's also a really good chart in your book on page 33 that shows you some examples of the correlation coefficient. So like I told you, the value for R is somewhere between -1 and 1. If it's 1, then it's a straight line with a positive slope. It would be exact. If it was 0, the data would have no correlation. And then if it was, if the R value was -1, it would be a negative slope. So here are some examples. This would be a really strong negative correlation. This would be a weak negative correlation. Right? This one would be no correlation. This would be a weak positive one. And this would be a strong positive one. Okay, so that's how we're going to use the R value. Alright, so once you've got that written down, I want you to read through the directions for example 1. And I want you to think about how we're doing that plot. So what I want you to start thinking about is, alright, if I'm going to do a scatter plot, what kind of scale am I going to use? What number do I have to go up to? Okay, what's my lowest X value? What's my highest X value? Alright, so when you read this, you should have found out what the independent variable is. Do you guys remember which variable is the independent variable? Yeah, it's going to be your x. Okay, so that means the temperature in Albany is going to be your x value, and that means the temperature in Sydney is going to be your y value. So I like to label those right away. And then we do have to make sure that we are taking that into account when we start to make our graph. So, okay, this is my x, this is my y. And you have some really wordy directions here. So Albany and Sydney are about the same distance from the equator. Do you guys know where Albany is?
New York.
New York. It's the capital of New York. Okay, and Sydney is? Australia. Any of you guys been to either of those places? Yeah, which one? Haven't been to Albany yet? Yeah, me too. So when you're making the scatter plot, okay, with Albany's temperature as the independent variable, just know that they're telling you that's going to be your x coordinate. Okay, and that's the first thing we're going to do is make that scatter plot. After that, we are going to name the type of correlation. You can see I've broken these down into steps for you. That's to help you when you're doing your homework so you don't miss one of these. And then we're going to sketch a line of best fit and find its equation. Okay, so lots of fun to be had with this problem. 2, 3, 4. So there's 4 different things that we're going to do. So when I'm making my scatter plot, the first thing I want to do is look at my values. So my lowest one looks to be about 31. What's my highest value? 70. Okay, so I gave you a chart, so I would see if I could fit this on here. Maybe I could go by 5, so 10, 20, 30, 40, 50, 60, 70. Yep, that just fits. Okay, and then 10, 20, so I'm going by 5, so I'm just going to label every other one. And then I'm going to label my axis, so this is the temp in Albany in degrees Fahrenheit. Now remember, your scales do not have to be the same. It just depends on what the values are. Okay, and if you were doing this on your homework and you were doing this on graph paper, you could also use the little indent. If you wanted to start at a different value, that's fine too. So here, it's like my lowest one is in the 40s and then going up to upper 60s. So maybe I'll do the same thing. 10, 20, 30, 40, 50, 60, 70. Okay, and that's going to be the temp in Sydney in degrees Fahrenheit. And now we're going to start plotting our points. Okay, so I have my XY, so 3165, so I'm going to estimate 31, go up to 65, 3466, and then just keep going. And then once you've plotted these, I do want you to do step 2. to, so tell me what type of correlation it is. And we're going to use our straight edge in just a moment. Correlation is this? Yeah, good. Okay, so negative because if you look at the data points, they are going down from left to right. So that is your step 2. Identify the type of correlation. It is a negative correlation. And then we are going to sketch a line of best fit. So I'm going to show you some of my lines of best fit. And then we're going to sketch ours together. So with the line of best fit, no two people are necessarily going to have the exact same line of best fit. Okay, you're going to have values that are really, really close, but it just depends on your graph. So when I made my graph by hand, this ended up being my line of best fit here. You can see I had a few points on the top, a few on the bottom, and it went through a few of them. That's what you're going to try to do, is get it as close as possible. So you wouldn't want it to go like too far up and then have a bunch underneath. You kind of want to balance that out. Okay, so we're going to try to sketch the line that best fits the data. This is why you need your straight edge. Okay, if you don't have them, I do have them on the cart over there. And again, like I wouldn't want to just go through these top points because then I'm missing a lot of the bottom ones. So I am going to try to get that as close as possible to go through the middle of the data. And sometimes you might have to do this a couple of times. I'm pretty happy with that one. So you can see I have a couple above, I have a couple below. So that's a pretty good line. Okay, notice I did mine in pencil in case I didn't think it was great. I could erase it and do it again. Okay, so you're going to sketch the line of best fit. You're going to try to go right between the data. So when you do that sketch, make sure that you use your straight edge. So use a ruler, or in a pinch, use a note card. Okay, but you do have to make sure that it is a straight line. Alright, so this is something that we did last week where we have to pick 2 points and we have to find the slope. So that's what we're going to do. You're going to pick 2 points on your line. So like I said, not all of our lines are going to be the exact same. So it would be a red flag to me if a bunch of people came in from their homework and they picked the same 2 lines, or the same 2 points. Okay, so I'm going to pick 2 points from my data. So for me, yeah, mine looks like it's going straight through that one and straight through really both of those. So I'll choose this one. That looks like the 6749. Okay, that's going to be one of my points, and then I'm going to use this one, which is the 3165. Okay, so I want you you to pick 2 points on your line as well. If your line does not go through those 2 points, then don't choose the same 2 points that I do, okay? But then once you have them, we're going to write them down. We're going to find the slope. This is my x1, y1. This will be my x2, y2. And I'm going to use my slope equation. Okay, so will you guys plug yours in and calculate, please? And then round to the nearest hundredth if necessary. Sometimes you might get a nice even slope. It just depends. So if you need to, we're going to be rounding to the nearest hundredth. We're going to be doing that for all of our values today. Now, even though the final value might not be the same, our slopes should all have one thing in common. Do you guys know what that is? Yeah, they should all be negative. Good. So I got about negative 0.44. Yours should be in that ballpark. Okay, even up to negative a half is fine. That's what I got. Really, as long as it's between negative 0.4 and negative 0.6, I think that's good. All right, and then that is the slope for our line. Okay, so the slope is negative 0.44. We're going to use that to create our line. Okay, so we did this last week. We solved using y equals mx plus b. Today I'm going to show you, or really remind you how to solve when you have the point slope formula. You guys remember the point slope formula? Start with y minus.
Then it's like x minus x1, y minus y. I don't
Yeah.
there's something in the middle, but I don't remember.
So when you're finding your equation, okay, your final equation is going to be in the form y equals mx plus b. And then what you can do is you can use the point slope formula to help get you there, which is y minus y1 equals m multiplied by x minus x1. And all you need is the slope, which we have. Again, you're using your slope, and then you're just going to use a point. I'm going to use the x1, y1 that I used for my previous step, which is 3165. So I'm just going to use that as my x1, y1. Okay? Really doesn't matter which point you use. From our previous step, just pick one of them. Alright, so this is y minus 65 equals negative 0.44, x minus 31. And then what we're going to do is distribute and simplify on the right side first. So anything on this side, if you multiply by x, is negative 0.44x. This is a negative times a negative, so I know it's going to be a positive. And then I'm just going to multiply these together. So negative 0.44 times negative 31. I got 1364. Okay, so you guys are using your values. Distribute.
Oh.
So we're just distributing, right? So the negative 0.44 times x, the negative 0.44 times negative 31, I'm distributing. And then my last step is to get y by itself, which will be me adding 65 to both sides. And then I will have my equation. 78.64. So this is the line of best fit. Now, remember what I said. I said there's going to be a lot of variation when we are doing this by hand, right? Because depending on where we draw our line, our points could be a little bit different that we choose, which means our slopes could be a little bit different, our y-intercepts can be a little bit different. But if we're using these models to make predictions, we want to be as accurate as possible. Okay, and that's why we have programmers who make beautiful applications that allow us to enter data, and the graphing calculator is going to do this computation for us to help us get the line of best fit. Okay? So you can do it without a calculator to get an estimation, but we're also going to do linear regression with a graphing calculator, and we're going to see how strong that data can be. So this is called LinReg with a graphing calculator. Okay, the reason why it's LinReg for short is in your calculator, that's what you will see. LinReg is linear regression. Okay, that's its nickname. So for example 2, we're going to look at a different set of data. So we have a group of anthropologists. Do you guys know what an anthropologist studies?
Someone who studies culture.
Yeah, a lot of times they do. Yep, they study humans, right? And so a lot of times they study human behavior. In this case, they are able to take the length of the femur, which is the thigh bone, and they can use that to estimate the height of a human being. So in the table, we have some randomly selected data, just called a sample. And then when we do part A, where we're making the scatter plot, we're actually going to do that with our graphing calculator as well. And then it says that you need to use the femur length as the independent variable. Okay, we're going to use the femur length as the independent variable. So that means in our chart, the length is going to be the x, the height is going to be the y. Okay, so this is my x, this is my y. So again, we are not doing this by hand. I'm going to show you how you can use your graphing calculator to do this. All right, so making a scatter plot of the data, and then the femur length is the independent variable. So that just means that's our x-coordinate. All right, so we're going to do things on the graphing calculator. I'm also going to write down the directions for you so that you can replicate this. So on your graphing calc, okay, what we're going to have to do is we are going to have to use the stat button. And when we use a button, a lot of times I'll make it a button. And then after you hit stat, you're just going to hit enter. So we're going to do that part together. Okay, so find the stat button. is right here. And when you press Stat, the first thing it says is Edit. Because that's exactly what we want, that's why we press Enter right away. Now, some of you might have an L1, you might already have some data points in for L1 and L2. If you do, this is really important. You have to press Clear. Do not press Delete. You have to press Clear. Okay, so if you press Clear, Enter, it gets rid of all the data in that column. So you have to highlight L1, Clear, Enter, and in list 1, do you guys have any ideas of what we're going to enter in list 1? Yeah, your X values, good. Okay, so in L1, we are going to enter the X values. In list 2, we need to enter the Y values. And yes, it needs to be in list 1 and list 2. If you are missing a list 1, please let me know. If somebody came before you and accidentally deleted it. To enter them in, you just have to type in the number and then enter. So 36, enter. 32, enter. Make sure that you put in the correct data points, because if you don't, you will not get the same thing as I do. And that will be the first thing I'll have you check, is making sure that you enter them in correctly. And then do the same thing for your Y. Put in your L2. Alright, so thumbs up if you've done that step. Alright. Alright, now normally, once you enter in data, you want to go to the graph, but we did not tell the calculator what we are graphing yet. Because we're doing a scatter plot, we are going to go to the y equals, and I'm actually going to have you write down the directions first. Okay, so if you are going to plot, you go to y equals, and then you have to arrow up to plot 1, and hit enter. Okay, so plot 1 should be highlighted. We'll do that part together. You do have to go to y equals. Oops, and yours looks like this. Okay, so when you go to y equals, you're going to arrow up until the cursor is on plot 1, and then you're just going to press enter. So it should look like this. Now I want you to graph. So go ahead and hit the graph button and see what happens. See what you see. Can you see anything? Why not? Oh yeah, if you guys have any equations from last week, will you clear those out? Wait, but you graphed this, you didn't have anything? Why? Our plots are on.
The range is too small?
Yeah, where are all of our data points?
Oh, far away.
Yeah, the x's are in the 30s at the very least, but what does this graph show us? This is just a 10 by 10. So mine only goes to 10 to 10, so we have to make the window adjustments. Okay, so adjust window to fit data. So there is a window button. So adjust window to fit data. Okay, so a lot of us already have the negative 10 to 10. To adjust the window, they're going to ask you for the x minimum and the x maximum. Okay, so because this is data, okay, the x min can be 0. What would be a good value for the x max, you think? Well, there's one that's above 40? Yep, there's one that's 46, so I would probably go up to 50. And then, so let's do that. So 0, 50. And then the next thing says XSCL. Do you guys know what that is? Yeah, the scale. And that just means, what do you want your graph to go by? Do you want it to go by ones? Well, if I'm going to 50, that's a lot of tick marks on there. That's when the line gets really thick and hard to see. So instead, we could go by what? Yeah, I would go by 5s. You could even go by 10s. That's fine. Okay, so I'm going to go by 5s. And then let's think about what we want our x or our y min and max to be. And again, I like to round up to nice numbers. Okay, as long as you have something that fits the data, I'm good. So for me, I want my minimum to be at 0 because that's the lowest possible for our data. And then the highest y value is what? 187. So if you want to go to 190, you can. I like to go to 200. So 0 to 200. And then what would be a good scale for this one? Yeah, I would go by 10s. If you don't change that to 10 when you graph, you're just going to see a really thick line. Because especially with some of these calculators here that are not flat, they just can't do all the pixels that are required. Okay, so now we can graph it. Oh, and we should see some pretty little points now. Okay, now they look like little squares. That's because that is the default. You could change it to points or pluses. If you don't have yours, you either did not adjust the window correctly, or maybe you accidentally turned the plot off. So double check that. Or maybe you entered some of your data wrong, and I'll come around. So if you aren't seeing what I'm seeing, you got to tell me so I can help you, okay? And then if you go to second stat plot, so second, the y equals button, this is another way that you could turn it on and off. Okay, you could highlight that, turn it on, off. You could change this. Okay, and then in our next step, we are going to find the correlation coefficient, R, and the line of best fit. So find the correlation coefficient, R, and the line of best fit. And then after that, we're going to interpret the slope of the line of best fit in context of the problem. I said look at page 33 in the text. That's just going to tell you more about the correlation coefficient, but we're going to do that with the line of best fit. So to find the line of best fit and the correlation coefficient, the first thing we'll have to do is turn on what is called the diagnostic. Okay, so it says look at page 33 in the text. That's going to tell you how to turn your diagnostic on. And then I'm actually going to give you the directions now. Okay? So what you're going to have to do is you're going to have to find the catalog. Can you guys find where the catalog is on your calculator? Have you seen that before on your calculator? It should be above the 0 button. So check this, see if yours is there.
Yeah, I found it.
Okay, so to turn the diagnostic on, we are going to go second and then 0, which is the catalog. So go ahead and do that with me. So second, 0, and this is what you should see. So a catalog is like an index. It starts with A. You can either arrow all the way down till D, but I have this little A in the corner, which means I can use the number or the letters on my calculator to help me go. So can you guys see mine are neon green? So it starts here, A, B, C, D, E, F, G. Okay, so I'm going to press D, and it takes me right to that part of the catalog. Again, you can always just scroll down if you would like. And then I'm going to select Diagnostic On. And I do that by pressing Enter. It takes me to the home screen. So I press Enter again, and then it's going to say Done. Okay, so what you're doing is you go to Diagnostic On. You press Enter. Then you press Enter again. And then it says Done. Okay, this is to get the R value. So the correlation coefficient is on now. Okay, so a lot of times when you take a test or a quiz, we'll actually clear out the calculator, which will automatically turn this off, so you will have to know how to turn that back on. You won't have to do it every single time, though. Okay, so now that you have yours on, as long as you don't clear your data out, it should be on. Okay, so now we're going to find the line of best fit. And to do that, I'm going to write out our instructions. So the line of best fit. Okay, we are going to use our Stat button. And then we are going to arrow over to Calc. So I'm just going to go Stat. So this is where we were before, but now I have to use my arrow to go over to Calc. Look up at me when you're at the screen. Okay, so Stat, arrow over to Calc. All right, and then do you guys know what we're going to push here? Yeah, the LinReg. Okay, so then you can either arrow down to it or you can just press 4. Notice that LinReg, next to it, it says AX plus B. That's really similar to what? Yeah, it's really similar to MX plus B. It's the same thing, except instead of M, what do we have? A. Okay, so I'm just going to press 4. Many of you will get this screen. Some of you might get the home screen. And you should say L1 and L2. And you can either just press enter, 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 enter until you get to calculate, and then press enter. Okay, but you should have these values now. Yes. Good. Okay, and if yours takes you right to the home screen, you can just press enter. Yep, enter. Enter. Okay, that's all right. Let's see if these over this part. The count and then those in. Yeah, all right, so can you guys see your A, your B's, and your R's? Okay, so for the line of best fit, all you need is your A and your B. Okay, so the slope is, and we're going to round to the nearest hundredth, A equals 2.91. Your y-intercept is B equals 54.04, because again, we're just rounding to the nearest hundredth, which makes your line of best fit y equals 2.91x plus 54.04. And my slope makes sense, because if I remember back to my scatter plot, it was going up from right to left. Okay, and this is your line of best fit. Now, when it's asking you to interpret the slope of the line of best fit, remember that your slope is just it's your rise over your run. And if you have a decimal, you can think of it as over 1. So what this means is, we're going to write this here. So in context of the problem, it means for each 1 centimeter increase in the length of the femur, the predicted increase in height is 2.91 centimeters. And again, I just got that from the rise over the run. So remember, the 2.91 is the y, that's your height. Okay, the 1 is your x, because it's 2.91x over 1. And then the last thing we have to look at is our R values. So find the correlation coefficient, which we have right here. So my R is going to be, I'm going to round to the nearest hundredth, 0.986 rounded. Okay, so do you guys know what that means? Is this strong or weak? Strong. Why? Good. Okay, so this is a strong line of best fit. Okay, that means this is going to be a really good model to make predictions. All right, so I want you to read C and D and see if you can set those up. Or at least think about it. It's okay if you're not 100% sure. Okay, so for C, they're telling you the length of the femur. You have to predict the man's height. Okay, so when we're predicting, we're going to be using that line of best fit that we just found. And think about what's going to be your input, what's going to be your output. So is the femur, is that related, the length of the femur, is that the X or the Y? Yeah, so what we're going to do is we're going to substitute this in for X. That's my X value. So if I look at my model, the man's height, that's going to be my Y. That's what I have to find. So Y is going to equal 2.91 times 41 plus 54.04. Okay, so we're going to calculate that. So 173.35. Okay, so we would say that his height is approximately 173 centimeters. Alright, and then see if you can set up the equation for D and solve that. Alright, so where do we have to plug in the 165? Yeah, and then wasn't this just like an Algebra 1 problem once we did that? Okay, because we have the 2.91x plus 54.04, and then we're just going to solve for x. Okay, so we're predicting the length of our femur, that's our x value. So I'm going to subtract the 54.04 from both sides. And then what did you get when you subtract? Good. Okay, and then we're just going to divide both sides by 2.91. My x value is about 38 centimeters. So her femur is about 38 centimeters. Alright, now you have special directions for your homework today. You're going to do numbers 1 through 8, but number 2 has to be by hand. The rest are going to be with your graphing calculator. You can handle that? Okay, so just number 2 by hand, the rest with your graphing calculator. Alright, so there's only one that you have to do by hand.